Hey everyone, so we're going to go ahead and move on in Unit 6 with a section on long division. And long division is something that we use in order to completely factor a polynomial or to determine if a factor is an actual factor of a polynomial or if a certain divisor is a factor. Okay, so just to kind of refresh on division in general, I want to do a quick little example just to kind of get our brain thinking about that again and what that looks like and how we do it. So if we wanted to do something like 29 divided by 9, something like this. Okay, we would first say, okay, this has 1 unit, so I'm going to see if it will go into the first unit here. Does 9 go into 2? Well, obviously not. So, okay, we move over. Does 9 go into 29? And when we look to see if 9 goes into 29, yes, it does go in. It goes in 3 times, right? So we write our 3 up here above our 9, and then we do 3 times 9, which gives us a 27. And then remember we subtract, right, to see how many is left over. So instead of say subtract, I'm going to say draw my line and change my sign. Okay, so when I subtract or when I draw my line and change my sign, when I combine, I'll be left with 2. Okay, so I want to go ahead and label what these things are. The thing on the top, we call this our quotient, right? What's left over down here, we call our remainder. And the thing that we are dividing by, we call our divisor. Okay, so these are all words we need to be conscious of, right? And then the number under here is our dividend, right? Okay, so why we care. When we're dealing with polynomials, we're looking to see if we're going to get a remainder. Because just like this 9 and 29, we can see that 9 is not a factor of 29 because it didn't go in evenly, right? We were left with a remainder. Now, if we had been left with a 0 here, then that would have meant that 9 went in evenly. So that's what this is talking about. This is saying if we have no remainder, if we have a 0 remainder, then that means that what we're given is a factor of the given polynomial, okay? If we have no remainder, if we do have a remainder, like in this case, right? If we do have a remainder, then it's not a factor because it didn't go in evenly. Okay, so that's what we're looking to do. Now, there's a few things to keep in mind. One, we want to make sure both of our polynomials are written in descending order. That means the highest power of x down to the constant term, right? Highest power of x down to the constant term. Then we want to make sure we fill in missing terms with a 0 placeholder. So let's look at this one down here. Our highest power of x is to the 4th. And notice this is in descending order because we have our highest power of x all the way down to our constant term. But if you notice, we're missing a power of x, right? This goes from x to the 4th down to x squared. So this means that we are missing our x cubed. Okay, so if we're missing an x cubed, we want to use a 0 placeholder, which we're just going to put in a 0 there. Okay, and then we're dividing by x minus 3, and it's not missing anything, right? It goes from x down to the constant, so we're good there. And then the third thing we want to remember is if our solution has a remainder, we want to make sure we represent it this way. We write our quotient plus whatever our remainder is over our original divisor. Okay, so again, those are the 3 things we need to be aware of. This is our divisor, this is our quotient, this is our remainder. Okay, so let's look at what that looks like with polynomials, okay? So I'm going to go ahead and scoot this up. Or actually, I may leave it to where we can see the 9 for reference. All right, so we're going to go ahead and put our divisor, x minus 3, out front. And we're going to be dividing into this polynomial. This is our dividend. So we have 2x to the 4th. Remember, we didn't have an x cubed term. So we're going to put in a 0 x cubed term or a 0 placeholder term, right? 0 times x cubed is just 0. So we're just putting in a 0 to hold that spot, okay? And then we have a positive 5x squared, a minus 7x, and a positive 38, okay? All right, so now we have that all written out. Just like with the 9, we did it with units, right? 9 is a 1 unit or a 1-digit number. So we see, does 9 go into the first digit? And if not, we scoot over, right? Same thing is true here, but we do it with terms. Since there's 2 terms in our divisor, we're going to scoot over 2 terms here, and we're going to write our first piece of our quotient above the 0x cubed, okay? All right, so let's start our long division. The way that we do it is we look at our leading terms. What do I have to multiply my leading term x by so that it looks like this leading term 2x to the fourth? Well, in order to make x look like 2x to the fourth, I need to multiply by a 2. And I also need to multiply by 3 x's, right? Because I need to go from 1x to 4x, which means I need an x cubed. So now, just like we did up here with the 9, once we know what we need, we multiply that by our divisor and write it below. So we need to take 2x cubed, multiply it by our whole divisor, and write it below. So you can distribute this in your head and write it below, or if you have a hard time with making little errors, little sign errors, I encourage you to write it out. I'm going to go ahead and just say we're going to do 2x cubed times our divisor, x minus 3, and write it here below. So now I can do this kind of right here and maybe not make mistakes. So 2x cubed times x gives me 2x to the fourth. 2x cubed times negative 3 gives me negative 6x cubed. Now, just like before, once we multiplied that 3 times our 9 and we put our 27 here, then we subtracted, right? Now, we're not going to call it subtracting because we have more than one term. And we know whenever we subtract more than one term, we have to distribute that subtraction to both terms. So instead of saying subtract, we're going to say draw the line, change the sign. So I'm going to draw my line and I'm going to change my sign. Now, I'm going to circle it because I know some of you don't have different colors to be using. I don't even know if you can tell that I'm using different colors here. So this one becomes a negative and this one becomes a positive, okay? And then I just combine straight down. So 2x to the fourth minus 2x to the fourth, well, those are opposites. They just cancel. Here I have 0 plus 6, which leaves me with 6x cubed, okay? Then I bring down my next term, which is a plus 5x squared. And the reason I bring down my next term is because we have 2 terms out front, right? And we can only do a division with 2 terms if we have 2 terms here, okay? So once we come down with this leftover, then we bring our next term down. And then we start the process over again. What do I need to multiply this x by so that it looks like this leading term, 6x cubed? Well, I know I need to multiply by a 6, and then I also need to go from an x to an x cubed. So I need a positive 6x squared. So again, just like we did with the 3, once we write what we need up here, we multiply it by our divisor and write it below. So we're going to take that 6x squared, we're going to multiply it by our divisor, and we're going to write it below. I'm going to go ahead and write it off to the side, 6x squared times our divisor, x minus 3, and then we're going to write that below here, okay? So 6x squared times x is 6x cubed. 6x squared times negative 3 is negative 18x squared. Okay, and then remember what we do, let me move this a little bit, what we do once we have distributed, now that we have it written below, we're going to subtract, right? Or for us, we're going to draw our line and change our signs. So the first one becomes negative, this one becomes positive, okay? And then we combine straight down. Notice our leading terms are opposites, so they cancel out. And here I have 5x squared plus 18x squared, which gives me 23x squared. And then I bring down that next term, which is minus 7x. And then I start it over again. What do I need to multiply my x by so that it looks like 23x squared? Well, I need to multiply by a 23, and I also need another x, right? So I'm going to multiply by a positive 23x. And then I'm going to take that positive 23x, distribute it to my divisor, and write it below. So out to the side, I'm doing 23x times x minus 3, and writing it here. So 23x times x gives me 23x squared. 23x times negative 3 gives me a negative 69x. And then once I have it distributed out, remember, I draw my line, change my signs. So this becomes a negative, this one becomes a positive. and then I combine straight down. My first two are now opposites, and I have a -7 and a +69, which leaves me with a +62x, and I have one more term to bring down, which is a +38. Okay, so one last time, what do I have to multiply x by to get 62x? Okay, notice I'm always just trying to make my leading terms match. I don't care about this 38. I just want to make x looks like 62x. So in this case, I need to go ahead and multiply by a +62. So I'm going to take that 62, distribute it to my divisor, and write it below. So 62 times x minus 3, and write it here. 62 times x is 62x. 62 times -3 is a -186. And then I draw my line and change my signs. First one becomes negative, second one becomes positive. The leading terms are opposites, so I go ahead and cancel them out. 38 plus 186 gives me 224. And I don't have anything else to bring down, so I'm done. Okay, so what this tells me is, remember, whatever is up here, this is my quotient. Okay, whatever I am left over with, this is my remainder, right? Yeah, I barely stuck it in there. Remainder. Okay. And then it didn't ask me specifically for just my remainder or for anything. So anytime we have a remainder, we want to express our solution like this. We want to write it as our quotient plus our remainder over our divisor. So this is my quotient. So we're going to write it as 2x cubed plus 6x squared plus 23x plus 62. And then we're going to add our remainder over our divisor. So remember, this is our divisor, the thing that we're using to divide the big polynomial. So we're going to write this as 224 over our divisor, which was x minus 3. Okay, so there's our solution. So if we're asked, was x minus 3 a factor of this polynomial, then our answer would be no, right? Because we had a remainder. And if we have a remainder, that means it did not go in evenly. Okay, so I can also go ahead here and conclude that x minus 3 is not a factor. Okay, I know it didn't ask me that on this, but on your homework there may be problems that it asks you to identify that. So remember, if we have a remainder that is not 0, then that means it did not go in evenly, which means it is not a factor of that polynomial. Okay, all right, let's look at a couple more just to get some more experience with this. So on the next one, it says, determine the remainder when 8x cubed plus 6x squared minus 7x is divided by 2x plus 1. So we know that we're going to take 2x plus 1 and we're going to be dividing that into this polynomial. First thing I notice is that it does not have a constant term, right? We have our x cubed, we have our x squared, and we have our x, but we are missing the constant term. Missing constant term. So that means we need to put in a 0 placeholder at the end. Okay, so when I write my polynomial under here, I'm going to write 8x cubed plus 6x squared minus 7x plus 0. Okay, so we have to have a representative for every single placeholder or place value between our highest power of x all the way down to our constant. Okay, all right, so we have two terms out here, so I'm going to move over 2 places, write my first number here. What do I have to multiply 2x by to get 8x cubed? Well, to go from 2 to 8, I need to multiply by 4, and to go from x to x cubed, I need to multiply by x squared. So I need to now distribute this 4x squared to my divisor and write it below. And I'm going to go ahead and write it out to the side. 4x squared times 2x plus 1, and write it here. So 4x squared times 2x gives me 8x cubed that I wanted, right? 4x squared times 1 is a positive 4x squared. And then I draw my line and change my signs. So this one becomes negative, and the second one becomes negative. So now you can see that my leading terms are opposites, so they cancel. And I have 6x minus 4x squared, sorry, 6x squared minus 4x squared, which leaves me with 2x squared. And I can't have just one term if my divisor has two terms, so I bring down that next term. Okay. All right, so now I start over again. What do I need to multiply my leading term 2x by in order to get this leading term, which is 2x squared? So I already have the 2, but I need an additional power of x, right? So I'm going to go ahead and multiply it by just a positive x, and I need to take that x, distribute it to my divisor, and write it below. So I'm going to go ahead and say x times 2x plus 1, and that's what I'm going to write below here. So x times 2x gives me the 2x squared that I needed, and x times 1 gives me a positive 1x, right? Then I draw my line, change my signs. So the first one becomes negative, second one becomes negative. When I do that, my leading terms are now opposite, so they cancel. And negative 7 minus 1 gives me negative 8x. Okay, and then I bring down that last term, which is a plus 0. And I just do it one last time. What do I have to multiply 2x by to make it look like negative 8x? Well, to go from 2 to negative 8, I need to multiply by a negative 4. And then I already have an x, so I don't need to multiply by x. It's just negative 4. So I'm going to take that negative 4, distribute it to my divisor, and write it below here. So negative 4 times 2x plus 1, write it below. Negative 4 times 2x gives me negative 8x. Negative 4 times negative 1, or sorry, negative 4 times positive 1 gives me a negative 4, right? And then I draw my line, change my signs, so the first one becomes positive and the second one becomes positive. Now my first terms are opposite, so they cancel, and 0 plus 4 leaves me with a 4. I have nothing left to bring down, so I'm done. So that means that this is my remainder. Number 4 is my remainder. Okay, and what's written up here is my quotient, right? And what's written out here is my divisor. Okay, so if I wanted to write my answer like I did on the last one, I would write my quotient, which is 4x squared plus x minus 4, and then I would add in my remainder over my divisor. So this would be plus 4 over 2x plus 1. But I'm not going to circle that because on this one it didn't actually just tell me to divide or find the quotient. It said determine the remainder. So if all it asked for is the remainder, then my answer here would just be 4. Okay, because 4 is what I got for the remainder. Now, because I got a remainder, right, I didn't get a 0, that means it didn't go in evenly, which tells me that 2x plus 1 is not a factor of this polynomial. Okay, again, it didn't ask for that, but you may have homework problems where it asks that. So be sure you're aware that if you get a remainder, that means it's not a factor. Okay. All right, so I want to actually make this next one your first practice problem. So I'm going to go ahead and call this number 1 practice, and I'm going to skip it for now. And your number 1 practice on the next page, I'm actually going to do this one as an additional example because it's a little bit different. Okay, so I'm going to do this number 1 practice problem as an example, and then when we get done with that, I want you to do this last one on page 16 and the number 2 practice. Okay, all right, so let me go ahead and look at this one, this first practice problem, which I'm doing as an example. It says determine the remainder. So again, we're just looking for the remainder, so we don't need to write out the whole quotient plus the remainder over the divisor. Okay, and they're giving us this polynomial. Notice we're not missing anything. It goes from cubed to squared to x to constant term, and we're dividing by 4x plus 5. So we're going to go ahead and put our 4x plus 5, and then we're going to write out our dividend, which is 4x cubed plus 5x squared minus 64x minus 80. We have 2 terms out front, So I'm going to move over 2 terms and put my first answer up here. What do I need to multiply 4x by in order to get 4x cubed? Well, I already have the 4, and to go from x to x cubed, I need an x squared. Okay, so I'm going to take that x squared, multiply it by my divisor, 4x plus 5, and write it here below. So x squared times 4x gives me the 4x cubed that I needed. And then I distribute my x squared to my 5, which gives me a positive 5x squared. And then I draw my line and change my signs. That makes this a negative and this a negative. And notice if they both become negatives, then they both become opposites and they both cancel out. So I bring down my next term, which is negative 64x. Now notice since I didn't have a term left over here, I don't have 2 terms, right? So there's nothing I can multiply here and get just 1 term, right? I'm going to end up with 2 terms. So you can either write a 0 here and scoot over to the next one, or you can just leave it blank and go ahead and bring down that negative 80, okay? Because I can only continue on with 2 terms if I have 2 terms written over here. So now my next number, because I'm using this negative 80, is going to go above it. So what do I need to multiply my 4x by to get negative 64x? Well, they both already have the x's, so to go from 4 to negative 64, I need to multiply by a negative 16. So I'm going to take that negative 16, multiply it by my divisor, and write it below. So negative 16 times 4x plus 5, I'm going to write that here. Negative 16 times 4 is negative 64x. Negative 16 times 5 is negative 80. And then I draw my line, change my signs, so this becomes positive, this becomes positive, and again, they both end up being opposites. So they both cancel out. Now, if everything cancels out and you don't have anything else to bring down, that means that my remainder is just a 0. Okay, so again, remember, this is our remainder. What's up here is my quotient, okay, and whatever was out front is my divisor. Now, just for practice sake, I'm going to go ahead and write out the answer as it looks, which would be my quotient, x squared minus 16, and then plus my remainder over my divisor. But since my remainder is 0, then this would just be my solution. I don't have to write 0 over my divisor, okay? Because my remainder is 0, that means that 4x plus 5 is a factor of the given polynomial, okay? Because we had no leftovers, it went in evenly, okay? Now, it didn't ask us for these 2 things on this problem. I just want to make sure you know how to write them if that is what you're asked for. On this one, it just said determine the remainder. So our answer is just the remainder, which in this case is 0, okay? All right, so I want you to go ahead and pause the video, and I want you to do this, this last example on the previous page as your first practice problem, and then number 2 on the next page as your second practice problem, okay? And once you've worked those and you're ready to check yourself, or if you get stuck, go ahead and play the video and we'll work through them, okay? All right, so on this example on the previous page, we should have 3x plus 6 out as our divisor. And then underneath, when we write this out, notice it's missing an x term. So make sure you put in a 0x, okay? What do I need to multiply 3x by to get 12x cubed? I need to multiply by 4x squared. So when I distribute that, draw my line and change my signs, I should be left with a negative 69x squared. Then I bring my 0x term down. What do I need to multiply 3x by to get negative 69x? A negative 23x. So I distribute that to my divisor and write it below. Draw my line, change my signs, and I should be left with a positive 138. I bring down my last term, which is 88. What do I need to multiply my 3x by to get 138x? I need to multiply by 46. So I do 46 times my divisor, write it below, draw your line, change your signs, and you should be left with a remainder of negative 188. Okay, so when we write out our answer here, notice it didn't specify that it only wanted the remainder or anything like that. So we're going to go ahead and write 4x squared minus 23x plus 46, and then we add our remainder over our divisor. Now, I don't mind if you write this as plus and then you put negative 188 over your divisor, or if you know that that plus and that negative, the negative wins, so you could just write minus 188 over 3x plus 6. Either way is fine with me, okay? All right, when we look at the second practice problem on the next page, and I guess I'm gonna have to hold this up. I got a glare here. All right, hold this up so there's no glare. There we go. Okay, so on the second practice problem, we have 2x plus 1 is our divisor. And notice on this one, we're missing an x squared term. So make sure you put in your 0x squared or your quotient isn't going to end up right, okay? What do I need to multiply 2x by to get 10x to the fourth? I need to multiply by 5x cubed. So I distribute that to my divisor, write it below, draw your line, change your signs, and we should be left with a negative 12x cubed. Okay, bring down your 0x squared. What do I have to multiply my 2x by to get negative 12x cubed? I need to multiply by a negative 6x squared. So I take that negative 6x squared, multiply it by my divisor, write it below, draw your line, change your signs, and you're left over with 6x squared. Okay. Bring down your next term, which is a positive 5x, and then start the process over again. What do I need to multiply my 2x by to end up with 6x squared? I need to multiply by 3x. So I take that 3x, I distribute it to my divisor, right? Write it below, draw your line, change your signs. You should be left with 2x, and then you bring down your next term, which is a minus 20, okay? What do I need to multiply my 2x by to get 2x? Even though it looks the same, we still need to put something up here, right, before we're done. So the only thing I can multiply by that won't change what I have is a positive 1. So I'm going to take 1, distribute it to my divisor, write it below, draw my line, change my signs, and I should be left with a remainder of negative 21. Now this one says find the quotient, and it tells me how to write my answer. So make sure you write or enter your answer as it's stated, okay, as it's requested. So we have 5x cubed minus 6x squared plus 3x plus 1. So that is the end of our long division section. So you should now be able to complete that assignment. Oops, sorry. You should now be able to complete that assignment on your Alta Newton homework. If you have any questions, please let me know.